Microsoft isn't just building the future of artificial intelligence, they're simultaneously constructing the world's most audacious and, some might say, desperate solution to an existential power crisis. The very ambition of their AI is forcing them into a monumental bet on nuclear energy, a move that fundamentally reshapes the future of global infrastructure. This isn't about buying more server racks. This is about generating power at a scale previously unimaginable for a tech company, and it exposes the brutal, hidden truth of AI's insatiable hunger. By the time we finish this deep dive, you will understand the unseen energy black hole that underlies every AI ambition, and how that relentless demand is pushing the biggest tech companies to become independent power brokers, remaking the very fabric of our energy grids. For decades, the story of Silicon Valley was a narrative of shrinking components and soaring software. Moore's law whispered promises of ever-increasing efficiency. But then, something fundamentally shifted. Around 2017, with the rise of deep learning and transformer models, a new kind of computing emerged, one that defied the old rules. Consider the scale. GPT-3, a model released in 2020, required an estimated training energy equivalent to more than 1,200 megawatt-hours. To put that into perspective, that's enough electricity to power the average American home for over 100 years. Now, imagine GPT-4, or the models that come after it, which are exponentially larger and more complex. Each new iteration of these advanced models isn't just a software upgrade, it's a massive, resource-intensive engineering project, consuming colossal amounts of computational power. The key players, companies like Google, Meta, Amazon, and of course Microsoft, all face the same looming physical constraint. Their data centers, the literal brains of the internet, are no longer just places for servers. They are becoming power plants in waiting. A typical hyperscale data center today can draw anywhere from 20 to well over 100 megawatts of electricity, enough to power a small city. That's before you even factor in the specialized infrastructure needed for AI. Training a large language model isn't a quick sprint. It's a marathon that can last weeks, sometimes months, requiring thousands upon thousands of highly specialized graphics processing units, or GPUs, all running at maximum capacity. These GPUs are not only expensive, they are incredibly energy hungry, each one consuming hundreds of watts, generating immense heat that then needs even more power for cooling. This isn't just a challenge, it's the defining problem of the AI era. Historically, tech companies would simply lease space in a co-location facility or build a data center somewhere with good fiber optic access and readily available grid power. They were consumers of electricity, like any other large enterprise. But the scale of AI's demand has shattered that model. Conventional renewable energy sources, while vital, often struggle with intermittency. Solar panels only generate power when the sun shines. Wind turbines only spin when the wind blows. For AI, you need an absolutely unwavering, 24/7, always-on power supply, because an interrupted training run could mean weeks of wasted compute time and millions of dollars down the drain. This is where Microsoft's gamble begins. They understood this fundamental shift earlier than most. In a stunning corporate pivot, Microsoft, a company known for software and cloud services, is now becoming a nuclear energy developer. They are no longer content to just buy electricity from the grid. They aim to produce it themselves, directly for their own data centers. This isn't some far-off research project, it's a strategic imperative. In 2023, Microsoft posted job openings for a lower-pitch principal program manager for nuclear technology, explicitly tasked with integrating small modular reactors, or SMRs, and other advanced nuclear technologies into their data center fleet. They're not just exploring, they are executing. Think about what this truly means. Before, the biggest tech companies competed on software features, on cloud scalability, on talent. Now, the absolute foundational layer of that competition has shifted. It is about power. If you can't guarantee massive, consistent, carbon-free energy, you simply can't build the next generation of AI. Microsoft's bet on SMRs is a game changer because it allows them to deploy smaller, more flexible nuclear power plants directly at or near their data centers, creating isolated microgrids that are immune to the vagaries of local utility companies or grid instability. These aren't the massive, multi-billion-dollar nuclear behemoths of the 20th century. SMRs are designed to be factory-built, then shipped and assembled on-site, drastically reducing construction time and cost. It's like moving from bespoke supercomputers to building block data centers, but for nuclear power plants. This is Microsoft deciding not to just buy gas for their cars, but to go out and build their own oil refinery right next to the highway. What changes when you understand this? You suddenly see that AI development isn't just a race for algorithmic superiority. It's a fast race for megawatt hours, a battle for reliable electrons, a contest to secure the very brute force energy required to crunch numbers at an unprecedented scale. Microsoft is, in essence, verticalizing their energy supply chain, an unheard of move for a company that doesn't traditionally operate in heavy industry. This gives them an unparalleled competitive advantage. While their rivals are still negotiating with traditional utilities, still wrestling with grid congestion and renewable intermittency, Microsoft is engineering its own power independence. Imagine the strategic implications: the ability to site an AI research lab or a massive inference cluster wherever they choose, limited only by their ability to deploy a modular nuclear reactor. The geography of AI is no longer dictated by fiber optic cables, it's dictated by power availability. This shift reveals three critical insights for how the tech industry now operates as a system. First, you need to understand that the pursuit of artificial general intelligence has an invisible energy tax that we, the users, will ultimately pay. Every time you ask a complex question of a large language model, every time you generate an image, every time an AI accelerates a process, you are drawing on an infrastructure that requires a staggering, continuous flow of energy. This isn't a future problem, it's happening now. Your local utility company might already be feeling the strain as new data centers demand power equivalent to tens of thousands of homes. Second, recognize that tech giants are not just becoming software monopolies, they are rapidly evolving into infrastructure monopolies of a far more fundamental kind. When Microsoft or Google begins to control its own power generation, they are no longer just cloud providers, they become utility companies, but without the public oversight and regulation that traditionally accompanies such power. This centralizes control over our most advanced computational resources into the hands of a very few, extremely powerful corporations. And third, you must grasp that this isn't just a corporate strategy, it's a geopolitical maneuver. Nations that fail to secure their own vast energy resources or fail to attract these energy-hungry data centers risk falling behind in the global AI arms race. The ability to deploy AI at scale is becoming a matter of national strategic importance, and the energy required to do so is the new oil. What does this mean for us beyond the headlines and the balance sheets of Silicon Valley? This monumental gamble, this desperate nuclear bet, pulls back the curtain on the true cost of our relentless pursuit of artificial intelligence. It forces us to confront a future where the very infrastructure of our digital world is intertwined with the most powerful and controversial energy source on Earth. This isn't just about Microsoft's corporate strategy, it's about the kind of world we are building, a world powered by an intelligence so demanding, so energy-intensive, that it requires a fundamental re-evaluation of how we generate, distribute, and consume power. It's a redefinition of what it means to be a technology company, blurring the lines between information technology and industrial power generation. The implications for competition, for the environment, for the very distribution of economic power are staggering. Who controls the electrons will control the intelligence, and that, in turn, will control an increasing share of our future. This is just one layer of the hidden mechanics shaping our future. There are countless more stories of corporate power plays, engineering decisions, and geopolitical stakes that remain obscured, and we will keep exposing them.